Hey, what's up guys? My name is Jan and I've recently found myself a new hobby, namely competitive programming, and I thought it might be cool to share with you some of the experiences that I've gained along the way while solving some of the interesting problems. And for the first problem, I chose a recent problem from a programming site called CodeChef, which is an Indian competitive programming site that runs periodic contests, and this is one of the recent contests called CookOff, July CookOff. And the problem caused quite a discussion on CodeChef forum. Some people found it to be quite ad hoc, which it definitely is. But then the question was, how do you approach such a problem? And I thought I'd share my approach to it, so we can see and you can all think whether it was a good one or whether you have a different approach to this. So without further ado, let's read the problem. So the problem reads as follows. You're given an integer d, and your task is to find a string s such that the following conditions are satisfied. First, s is non-empty, and its length does not exceed 7 times d. Second, s contains only lowercase English letters. And third, which is the most restrictive and most interesting condition of the whole problem, namely the number of distinct substrings in S minus the number of palindromic substrings in S equals D. So here, when counting palindromic substrings, a substring that occurs multiple times should be counted multiple times. And this is one of the first confusing aspects of this problem. So the palindromic substrings of S should be counted with multiplicities, but just regular substrings of S must be counted each one just one time. And I guess this is the condition that made people feel that this is somewhat artificial problem. Another point where people probably got confused was the 7 times d. So what does the 7 do here? And in the end of the day, it turns out that this 7 doesn't really play much of a role here. There could be other actually smaller constants. First, what can I think when I read about such a problem? It's definitely a construction problem. So you have to come up with some sort of a construction. Probably there are several strings that give rise to the same d. So probably your task is to find a family of such strings that would be easy to construct and that would give you access to all the integers d. So observe that you have to give a construction for every integer d, so positive integer d, obviously. So you have to give a construction for d equal 1, d equal 2, d equal d 3, and so on. So all you have to come up with is a family of strings that would give you d1, d2, d3, d4, and so on. The only question is how to construct such a family, how to come up with such a family, and this is not clear at all. So whenever you have such a problem, what you first want to do is you have to get a feeling of this problem. So you have to understand what these conditions really do here, and what are these? What does this difference in number of distinct substrings minus number of palindromic substrings, how does it behave? How does it work? And when you start working this out by hand, well, what would you do? Well, you would probably first try stuff like you would first try string A, and then you would probably, you would probably try string A, and then you'll probably try A, and see, well, what this gets you. Then you will probably try AB, and then we would probably try AAB, and then we would probably try AABB, and then we would probably try something like AAAB, and so on and so forth. Then you would probably try ABC, you would probably try ABBC, AABBCC, and so on. And probably some of these would get you somewhere, but which one, I don't really know. And when you start working them out by hand, then it's pretty easy to mess this up. So it's pretty easy to miss some of the subsets, to mess it up, or whether you would need to count the subsets with multiplicities or without. So how do you try these strings in a sufficiently fast and reliable manner? And here is where we actually can make use of the fact that we are at a programming competition. So we actually can write a program to actually try out these strings. So my approach was indeed not to start from writing the solution to the problem, but first a testing program to input a string and then compute this required difference for various strings. So I start off by reading a string from the command line. Let the string be S. We also will need the length of this string. And now let's start computing. First, we need to count the number of distinct substrings of this string. And whenever we need to count something distinct, then it's a good idea to use a set data structure. So let's take an empty set data structure. Let this stand for counter, this CNTR, and let's go through all of its subsets. This program doesn't need to be very efficient. Square or cubic complexity would be fine, because you're only going to run it on small strings to get the idea how this thing works. So we're fine with having double loops and stuff like that. So we are going to have substrings from position I to position J. So the first position is going to be in range L. And inside here we're going to take another loop in range that runs from I to L, and we will add to this counter set a substring of S that goes from I to J. Well, but since Python has substrings such that the last position is excluded, we will be running the substring from I to J plus 1. But this is just a technicality. And to be on a safe side, to see whether we've accounted for all these substrings, we will also print it out on the console. So this is why I like Python for competitive programming. It's very easy to print all kinds of stuff like sets, which is more complicated in other languages like C++, for instance. Okay, so these are now the unique subsets or substrings of this string S. And now let's also compute all the number of all palindromic subsets of this string. And since now we need to account for all of the palindromic substrings separately, we are going to have them in a list data structure. So let's initialize a new list data structure, LST. And again, we are going to be running through all the substrings, and figure out whether this substring is a palindrome or not. So again, we are going to have for I in range L for the first index, and for the final index we are going to run again for j in range I, L, and we will identify substring of S from positions I to j, and again we need to go until j plus 1 because Python excludes the last one. And now we check if this string is a palindrome, and for this we check if st is equal to st reversed, and Python provides us with very nice shorthand for reversing a substring, a string. So this -1 basically says that we go backwards through the string, and that we do not specify starting and ending points. Then this basically means that we go through all the string. So this equality checks whether we have a palindrome, and if we do, we add or append this string to the list, and we're done. So we can print also out this lst, and finally we will print out the difference of the cardinalities of these two data structures. So it's going to be len counter minus len lst, and this is actually the number that we're looking for. So let's run this program. Okay, I made a syntax error. Sorry for that. Okay, and the same here, of course. Also have to write it here. Okay, now it seems to be syntax correct. Okay, and now the program is expecting an input from us. So let's see what happens with A. So there is one substring. It's also palindromic, so the difference is 0. But what happens if we input AA? So this difference turns out to be -1. If we have AAA, then it's -3. If it's AAAA, it's -6, and so on. So these seem to be negative triangular numbers. So let's try something else. So let's try AB. So AB gives us 1. So this is good. So we constructed 1. Let's see whether we can construct 2. Let's see what happens with AAB. Oh, it's still 1. AAA, B, oh, it's 0. Oh, that's not the way to go. So what else can we try? AB was 1, so let's try AABB. Aha, that's 2. And so let's see whether this pattern continues. And if we try with AAABBB, then indeed it gives us 3. AAABBB gives us 4. And so it seems that it's a required construction, and it's easy to see that it indeed is. So if we take, let's say, string like AAAA and BBB, then the number of distinct substrings you can count as follows. So first there are substrings that only consist of A's. So, and it's easy to see that there are exactly D of them. Where D was this input number. If we put together DAs and DBs, so indeed, so there is substring consisting of 1A, consisting of 2As, 3As, and so on, up to DAs. And the same with Bs. So there are D substrings that only consist of Bs, So altogether we have D plus D, and then there are substrings consisting of first A's and then B's, and it's easy to see that there are D times D of them. Namely, you can have first any of 1, 2, 3 up to D A's, and then 1, 2, 3 up to D B's. So altogether there are D squared plus 2D distinct substrings. And when we start counting palindromic substrings, then we see that they can only be of the form some A's or of the form some B's. And as we have DA's, then all of the palindromic substrings are exactly basically pairs of elements. So all the palindromic substrings of form AAA are given by starting index of the substring and ending index of substring. So basically all of the pairs, and it's easy to see that there are D times D plus 1 over 2 pairs of D elements. So this is the number of palindromic substrings of form A, and of course the same holds for the substrings of form B as well. So altogether we have D times D plus 1 of palindromic substrings, which equals D squared plus D. And so the difference between these two values is exactly D as required. So in the end of the day, the resulting solution is as follows. So first there are D test cases, and for each of the test cases we have, okay, let me also save this as a Python file. Okay, and for of these test cases there is just one input number. Let's read it in. And for output we need to first output the length of the string. So this is 2 times t. Sorry, it's 2 times t. And then we need to output the string, which is first DA's and then DB's. And this is a complete solution to this problem. This passes all the tests. So you see that the solution is actually very simple, but it's not easy to come up with, and to come up with it more easily, we can basically write a testing script to get the idea how a solution would look like. That's it for this episode. I hope you liked it, and let's see you next time.